Okay, so today we're going to talk about parallel lines and transversals. Now, transversal is any line that crosses or intersects two or more other lines. And so you could have a transversal through other two lines that are not parallel, but today we're going to talk about a special circumstance where the two lines are parallel. And if you happen to have a transversal that crosses, intersects two parallel lines, there are certain special characteristics that happens. Namely, a lot of these angles are going to be congruent, they're going to be same, and some of the measures are going to be supplementary. So that's what we're going to look at today. So our goals, our essential question today is to prove and use the results about parallel lines and transversals. We're going to use properties of parallel lines to solve problems. So we're going to have a lot of theorems today, but we're going to start with the first postulate, which is a corresponding angles postulate. So it says if two parallel lines are cut by a transversal, so we have two lines here, and we know they're two lines because it's indicated by this little triangle arrow shape right there inside the other arrows on the outside. So that's how you indicate if two lines are parallel. Again, so you could do one triangle or one arrow inside or two arrows. So that means they're parallel to each other. Then the pairs of corresponding angles are congruent, which means that if you think of these two streets and this transversal is the intersection of those two streets, if you're standing on the same corner, so here example number one is on the top right corner of that intersection, and then you have the other intersection here, number two, angle two is also on the top right corner. So any corresponding angles which are same location on the intersection, they are always going to be congruent as long as these two lines are parallel. So angle 1 and 2 are congruent. Now we have another corresponding angles here on the left side. So I put with the two arcs with the blue. So those two, which are not named here, but we could have named them 3 and 4, they are also corresponding angles and they're also congruent. Now, we could have also named the bottom ones here, like 5 and 6. So the bottom right corner will be corresponding to the bottom right corner here as well. And then same thing for the last bottom left corner here, and then the left corner here. So you have 4 angles here, and you have the matching corresponding angles at the bottom, and they're always going to be same measurement. They're congruent as long as these two lines are parallel. All right. So using that, you could actually prove a lot of these other theorems. So the next one is the alternate interior angles theorem. So again, if two parallel lines are cut by a transversal, again, you can tell these two are parallel because you have the little arrow inside, the other arrows outside there. So these two lines are parallel. Here's a transversal that intersects both of them. And the pairs of alternate interior angles are also congruent, which means alternate means they're on the alternate side of the transversal, which means on the opposite side of this transversal. So angle 3 and 4 are on the alternate side. So angle 3 is on the left side of the transversal. Angle 4 is on the right side of the transversal. So they're the alternate, and they're both inside of the two parallel lines. So that's the alternate interior angles, and they're also congruent. So angle 3 here and angle 4 here are congruent. And then there's the other pair of alternate interior angles in blue. So that angle, we could call that angle 5, and then angle 6, if we were to call that. Those two are also alternate interior angles, and they will also be congruent. Okay, so there are lots of angles when you look at two parallel lines intersected or cut by a transversal, which just means another line that intersects both of those lines. Then alternate interior angles are going to be all the same. They're going to be all congruent. Okay. Now, not only that, there's lots of other theorems here as well. So we have this thing called consecutive interior angles. Another name for consecutive interior angles is same side interior angles. So once again, you got two parallel lines indicated by the arrow here inside. So two parallel lines are cut by a transversal, which is the line that intersects two or more lines here. Then the pairs of consecutive interior angles, or it's also called the same side interior angles, they're supplementary, which means that they add up to 180 degrees together. So here, consecutive or same side means they're on the same side of the transversal. So 5 and 6 is on the right side of the transversal. So that's why the consecutive interior, because they're both inside of the two parallel lines, right? So consecutive interior or same side interior angles are supplementary. That means if I add the measurement of angle 5 and measurement of angle 6 together, it's always going to equal to 180 degrees. That's what we mean by supplementary. We already talked about that before as well. And then the other side as well. So the two same side or consecutive interior angles on the other side here in blue, those two will also add up to 180 degrees, right? We already looked at the alternate interior angles. That's why I put one arc here and one arc. So those two are, we already know, are congruent. And these two with two arcs are another pair of alternate interior angles. So those are also congruent as well, right? So same side or consecutive interior are supplementary. They're not same, but they are supplementary, meaning they add up to 180 degrees together all the time, as long as these two lines are parallel. The next congruent angles are what's called the alternate exterior angles. So it's similar to the alternate interior angles, except this is exterior. They're outside of the two parallel lines. So you can tell here the angles 7 and 8 are on the alternate side or the opposite side of the transversal. So 7 is on the left side, the 8 is on the right side, but then they're outside of the two parallel lines. So that's why it's exterior. So alternate of the transversal and outside of the two parallel lines. So then these two, 7 and 8, are also congruent. And it's not named here, but the other angles here in two arcs and two arcs. So if that's 9 and 10, those two alternate exterior angles are also going to be congruent. So lots of angles that are going to be same when you have two parallel lines cut by a transversal. The last theorem is called the perpendicular transversal theorem. So what that means is that if a transversal, which means this line that intersects the two parallel lines here, if the transversal is perpendicular to one of the two parallel lines, so let's say it's perpendicular to the top one, well then it's automatically perpendicular to the bottom one, the other one as well. So if it's perpendicular to the first one, it's going to be perpendicular to the second one. That's kind of obvious because that's corresponding angles. If you look at our corresponding angles postulate, so the top right angle there is going to be same as the top right angle here. They're both 90 degrees, 90 degrees. So that's why it's perpendicular. Perpendicular by definition means that it's intersecting and forms right angles there. All right. So those are some theorems and postulate that you need to remember. So now let's take a look at some examples to see how these postulates and theorems work in terms of finding some angle measurements or finding some missing angles. Okay. All right. So here we have this parallel lines here. So we know they're parallel because again, we got the lines, but we got the arrow here and we got arrow there. So we got another arrow inside the two arrows at the end. So that tells you this line and this line are parallel. And then we got this transversal that intersects both of these, right? So it tells you here that measurement of angle 1 is 118 degrees. So angle 1 here is 118 degrees, right? So given that information, we can figure out all these other angles using the postulate and the theorems that we just looked at. right? So angle 2 is linear pair. That's what we looked at before, right? So angle 1 and angle 2 together form a straight line, right? So here, angle 1 and angle 2 together, they form a straight line. So that's the linear pair postulate, which means that they're going to add up to 180 degrees. So we can figure out angle 2 by just doing 180 minus the measurement of angle 1, which is 118. So that gives you 62 degrees. So that's linear pair postulate there. So angle 2 is going to be 62 degrees there, right? And then angle 3 is going to be corresponding to angle 1. See how angle 1, if you were to kind of think about this as intersection, that's on the top right corner. And then the other intersection here, angle 3, is also on the top right corner. So that means angle 1 and angle 3 are same, they're congruent, because they're called corresponding angles. They're on the same corner of the intersection. Top right corner there, top right corner there. So measurement of angle 1 is measurement of angle 1 and 3 is same. So that's both 118 degrees, and that's corresponding angles postulate that we just looked at. Okay? So then that's also going to be 118 degrees. Now angle 5 here is going to be congruent to angle 2 because that's the alternate interior angles theorem, right? So we already found angle 2 was 62 degrees, right? So angle 5 is going to be same as measurement of angle 2, which is also 62 degrees, because that's the inside of the two parallel lines and on the alternate side of the transversal. So 2 is on the right side, the 5 is on the left side of the transversal. So that's the alternate interior angle theorem that we just looked at. So measurement of angle 2 is 62. So measurement of angle 5 is also 62 degrees. They're always going to be the same. Angle 4, there are lots of different ways to figure that out because we already have so much information here. But angle 4 is also going to be congruent to angle 1 to begin with. And it's also going to be congruent to angle 3 because that's vertical angles, right? So there's lots of different ways you can figure this out. But angle 1, angle 4 are alternate exterior angles because, again, 1 and 4 are outside of the two parallel lines, and they're on the alternate side of the transversal. So they're also going to be congruent. So that's also going to be 118 degrees, same as angle 1, the alternate exterior angle theorem. So that's how we can use some of the theorems and the corresponding angle postulate to figure out any of these angle measurements given just one of them. Okay. All right, so let's continue with this. So here we have this kind of a parking lot, design here. So this is where you would, kind of go in to park here. And so we're trying to figure out the measurement of angle 1, given that these are all parallel lines, right? Because all the parking stalls are painted by parallel lines so that you don't get into the other cars. So here, this angle is given to you as 80 degrees, right? And angle 1 are what we call the consecutive interior angles. So if you were to think of this as parallel lines, and this is a transversal that intersects the two parallel lines. And so that's both inside of the two parallel lines, and it's same side or consecutive of the transversal that's right here going horizontally. So these two are going to be supplementary, which means that they add up to 180 degrees, right? So measurement of angle 1 plus 80 degrees is going to equal to 180 degrees. So you subtract 80. So measurement of angle 1 is going to be 100 degrees because 100 plus 80 is 180. So that's using the consecutive interior angle theorem. All right. So you can use any one of those postulate or theorem to figure out any of the missing measurement here. So once again, here, if we look at this picture, the measurement of angle 6 is given to you as 53 degrees, right? So with that information, so if that's 53 degrees there, we can figure out all these other ones because once again, these two lines are parallel. We know by that symbol there. And then this is a transversal that intersects both of those lines. So angle 7 is going to be congruent because 6 and 7 are what we call the alternate interior angles. They're inside of the two parallel lines, and they're on the alternate side of the transversal. So the 7 is on top of the transversal, 6 is in the bottom of the transversal, and they're both inside the interior of the two parallel lines. So therefore, they're going to be exactly the same. So that's also 53 degrees, right? Now, angle 8 is going to be using the linear pair postulate, right? So 7 and 8 are going to add up to 180 degrees, again, because together they form a straight line or straight angle. So that's just 180 minus 53, and that's going to be 127 degrees, right? Now, angle 9 is going to be congruent to angle 8, right? Or you can use the consecutive interior angles with 6 and 9, or you can say vertical angles with 8. Either way, they're all going to be the same answer. So 8 and 9 are vertical angles. That's a vertical angle theorem, right? Remember the opposite corner when two lines intersect are congruent. So that's going to be same as angle 8, which we already figured out is 127 degrees. So you can use a lot of different ways to figure out any of these angles because something special happens when the two lines are parallel. Okay? So then here we can, again, use all of those theorems in the postulate to solve for the x here. So we're given that this angle here is 39 degrees, right? And the angle 1 is going to be congruent to 39 degrees, right? So measurement of angle 1 is going to be same as 39 degrees. Why? Because that's the alternate interior angle theorem, right? So that's the alternate interior angle theorem, right? So that's the symbol for angles theorem. So I'm just abbreviating here. That's the alternate interior angles theorem because it's the alternate side of the transversal, right? Here's a transversal, 39 degrees is on the top. The angle number 1 is at the bottom. So that's the alternate side of the transversal. And they're both inside interior of the two parallel lines. So those two are always going to be congruent. So measurement of angle 1 is going to be same as 39 degrees. And then to figure out the 7x plus 1 here, angle 1 and this angle that we're trying to figure out is linear pair postulate, right? So that's a straight line. So that's a linear pair postulate because angle 1 and then this angle, if I were to put the measurements there, so I'll put it like this. So angle 1 and that, right? If you add them together, that's going to be a straight angle, which is going to be 180 degrees. They're supplementary. So measurement of angle 1 is 39 degrees. We just figured that out. And then that's going to equal to 180 degrees. So 39 plus 1 is 40. So we subtract 40 from that 180. So that's going to be 140. And then we divide by 7. So 140 divided by 7 is going to be 20. So x equals 20. And if I plug it back in there, that should help you to figure out that measurement. But this one, we're just trying to figure out the x there. Okay. So again, you can use alternate interior, linear pair, alternate exterior, corresponding, consecutive interior, all of those, right? So then we can use that same theorems and the postulate to figure out the value of x here. So here, this is right angle. That's 90 degrees right there, right? So then this is also going to be 90 degrees because this is, again, parallel lines, right? If transversal is perpendicular to one of the lines, then it's going to be perpendicular to the second line. So this is also going to be a right angle. And you also know that because these are corresponding angles, same right corner and then same right corner. So you just make 3x equals 90 degrees, right? Because it has to be a right angle. And then divide by 3. And that's going to give you 30 for the x, right? So that's using the either corresponding angles postulate, because that's the same upper right corner, or you can use the perpendicular right angle, because it's perpendicular to one of the two lines, and it's going to be perpendicular to the other line as well. Now, these two are going to be congruent because that's the alternate exterior angle theorem. So it's on the alternate side of the transversal, right? This is at the bottom, that's on the top, and it's on the outside or the exterior of those two parallel lines. Again, how do we know they're parallel? By the arrow inside the other arrows at the end. So you just make those two equal to each other, because the alternate exterior angle theorem tells you that these two angles are congruent. So their measurements are going to equal. So you make 7x plus 1 equal to 10x minus 50. And then you have to bring the variables together to one side first of the equal sign. So cancel that out. So 1 equals 10 minus 7 is 3x minus 50. And then add 50 to cancel that out, and add 50. So you're going to get 51 equals 3x. And then divide by 3. So divide 51 by 3. So that's going to be 17. So x is going to equal to 17 using the alternate exterior angle theorem on that one. Okay? So that's how we use all of those theorems to solve for the variable, because we know they're going to be congruent. A lot of these angles are going to be congruent. Okay? All right. So that's just the kind of a quick notes on all of the theorems and the postulates about the parallel lines and the transversal. So these are all kind of congruent angles, except for the consecutive, the same side interior angles, right? Everything else is same except the consecutive, the same side interior angles, which are supplementary, which means they're not necessarily same. They're going to add up to 180 degrees. Okay? All right. Thank you very much.